Now next topic is piecewise interpolation. Piecewise interpolation. Already you know what is interpolation. Now let us see piecewise interpolation. Generally, to have uh, reasonably accurate results using interpolation, one has to use polynomials of higher degree. Polynomials of high degree. High degrees means what? Linear interpolation is first degree, but to get more accurate result we have to use third order, fourth order or second order, like that, not linear. Okay, but with the polynomials higher degree, with the polynomials of high degrees, not only the computational becomes costly, not only the computational becomes costly, but also the computed results become unreliable because of a round of errors. See, what is the meaning of this statement? When we use higher degree polynomials, higher degree means third order, fourth order, then the derivation itself is very complicated. And whatever the results we will get, that contains some error. Round of errors means what? I already told you, 0.3989, some 8 like this, then it is truncated to what? 0.399 like this. That means this is round of error. Okay, this much. Then so there is some complexity by using higher degree polynomials. Therefore, in order to keep the degree of the interpolating polynomial small, in order to keep the degree of the interpolating polynomial small, and also to achieve accurate results, we use, that means what? Higher degree polynomials becomes computationally cost. Therefore, to use polynomials of smaller degree and to get accurate results, we use piecewise interpolation. This is the concept of piecewise interpolation. That means by using smaller degree polynomials and to get more accurate results, we have to use piecewise interpolation. Here what we did, we subdivide the given interval. In piecewise interpolation, we subdivide the given interval AB into a number of subintervals. Let me denote the subintervals xi minus 1 comma xi for I equal to 1 to n, and approximate the function by some lower degree polynomial, by some lower degree polynomial in each subinterval, lower degree polynomial in each subinterval. This is the concept. What is the meaning? Subdivide the interval AB into some finite number of subintervals, and in each subinterval assume the function with a lower degree polynomial. Lower degree polynomial. For example, see, let us subdivide the interval, closed a comma b, where a equal to x0 less than x1 less than x2 less than and so on less than xn equal to b, into a number of non-overlapping subintervals, each containing 2 or 3 or 4 nodal points. Okay, what is the meaning of this? Let me explain. This is x0, this is x1, x2, x3, x4, x5, for example 6 totally x0 to x6, 7 nodal points. The interval and the corresponding function values f of x0, f of x1, f of x2, f of x3, f of x4, f of x5, f of x6. This is the data. Then what is the thing here? By choosing, see, by taking 2 nodal points, this is the subinterval, this is the first subinterval, one can say this is the first subinterval, this is the second subinterval, this is the third subinterval, fourth subinterval, fifth subinterval, sixth subinterval. Now if I consider this subinterval x0 comma x1, if I consider these 2 points, then 2 points gives first degree polynomial, linear polynomial. Similarly, if I consider x1 x2, this is also linear, x2 x3 linear, x5 x6 linear. If I consider 2 points, I will get linear polynomial. If I take 3 points, x0 to xt, 3 points means I will get what? Quadratic polynomial. Now here from x2 to x4, now x4 to x6, quadratic polynomial. Okay, and this is called piecewise linear polynomial, and this is piecewise quadratic polynomial. Now if I consider, for example, if I consider 4 points, 3 points over now, x0 to x3, next x3 to x6, then I will get piecewise cubic polynomial. If I consider 4 points, piecewise cubic polynomial, like that. Okay, therefore when I consider 2 points, I will get piecewise linear, 3 points piecewise quadratic, 4 points piecewise cubic polynomial. Then what? By considering 2 points, we construct the corresponding linear. For 2 points we construct linear, or for 3 points we can construct quadratic, or for 4 points I can construct cubic polynomials fitting the given data on each subinterval, Okay, this is the idea of piecewise interpolation. Now let us see piecewise linear interpolation. Okay, and what is the idea here? We have n plus 1 distinct points. We have n plus 1 distinct points. What are the points? x0, x1 up to xn, and we want to determine linear interpolating polynomial. We want to determine linear interpolating polynomial. In each subinterval. Okay. Then in each subinterval, what is the subinterval? xi minus 1 comma xi for I equal to 1 to n. 1 to n. The subintervals are called the subintervals are called finite elements, or one can say simple word line segment. What is the meaning? This is x0, this is x1, this is x2, and so on. This is the ones x2, next x3, next x4, like this. This is the first element, this is the second element, this is the third element, fourth element. Each one is the line segment. This is called finite element. Okay. And the points what are the points? x0, x1, and so on, xn are called knots or grid points. Then what is how to sketch or using in each subinterval? You write like this. Next slide. In each subinterval, you approximate the polynomial as linear. We have to approximate the polynomial as linear. So what is the idea here? Using the linear, you write Lagrange interpolating polynomial. You know what is a Lagrange linear interpolating polynomial? We have for each x belongs to the subinterval xi minus 1 comma xi. This is each subinterval, means x0, x1, x1, x2, x3, x3, like that. The piecewise linear interpolating polynomial is what is the idea? We are approximating in each subinterval, we are approximating the polynomial by using linear Lagrange polynomial, and take that one as pi1. What is interval? xi minus 1 to xi. Then how to write Lagrange's interpolating polynomial for 2 points? Only for 2 points. This is xi minus 1 and this is xi. Okay, this is the subinterval. Now in this one, first x minus 1, replace x by xi minus 1. This is multiplied by what? Function at xi minus 1 plus next x minus xi by replace x by xi minus 1, and this is function value at xi. Okay, this is for what? This is for I equal to 1 to n. Okay, this is linear Lagrange polynomial. Okay, and one can write what is the meaning of this? If I want to draw the graph, this is 0 and this is x0, this is x1, this is x2, this is x3, and x4, and so on. In x0 comma x1, this is the linear, this is the first subinterval. In this first subinterval, I can draw straight line like this. Linear means straight line. Next interval is what? x1, x2. In x1, x2, I can draw the line like this up to here. Now in x1 x3, in x1 x3 I can draw the curve like this. This is approximate only. In x1 x3 x4 I can draw the curve like this. Okay, so this is my piecewise linear polynomial. This is mine. This is this one, this one, this one, this one. In each subinterval, the polynomial is approximated by a straight line. This is called piecewise linear interpolating polynomial. Okay, now let us consider one problem based on piecewise linear interpolation. Obtain the piecewise linear interpolating polynomials for the function f of x defined by the data. What is the data? X versus f of x is given 1 2 4 8 3 7 21 73. Hence estimate the values of f of 3 and f of 7. Solution. First one, what is the first subinterval? In the interval, what is the first subinterval? 1 comma 2. First subinterval is what? 1 comma 2. Now let us assume this interval as, one can write this is xi minus 1 to xi. Okay, then in the interval 1 comma 2 we have, what is the first polynomial? We have the linear interpolating polynomial as, what is that? P1x. Let me consider P1x equal to, what is the formula? X minus xi. By replace, for first interval I will write, replace x by xi minus 1 f of xi plus x minus xi minus 1 by xi minus 1 f of, this is xi minus 1, this is fi, this is I minus 1. Okay, this is I minus 1. Then what is this? Is xi, this is, and here this is 1 2, these are x values, and function values are what? 3 7. So this is f of xi minus 1 f of xi. So what is the polynomial? We have substitute polynomial x minus xi, this is xi minus 1 and this is xi 2 by 1 minus 2, this is 3, plus x minus 1 by this is 7 minus, sorry, 2 minus 1 into 7. So what is this is equal to, after simplification, the polynomial in the first subinterval is 4x minus 1. Now in the second subinterval, in the interval, what is that interval? 2 comma 4. Now assume this as xi minus 1 xi. So what is the data? X versus f, 2 4 and this is 7 21. So this is fi minus 1 and this is fi, right? Okay, therefore what is the polynomial? Piecewise polynomial is, shall I write directly? X minus xi, x minus, this is xi minus 1 and this is xi, by 2 minus 4 multiplied by 7 plus x minus xi minus 1 by 4 minus 2 into 21. So this gives 7x minus 7. And in the interval, in the subinterval, or in the interval, what is the interval? 4 comma 8, last interval, and consider this as xi minus 1 to xi. That means what? X f, This point is 4, 8. This is xi minus 1. This is xi, and this is 21. That means fi xi minus 1, and for 8, 73. So this is f of xi, right? So what is the interpolating polynomial? Linear x minus xi, 8 by 4 minus 8 multiplied by 21 plus x minus 4 by 8 minus 4 multiplied by 73. Okay, and the result is 13x minus 31. Hence, lastly, hence the piecewise linear interpolating polynomials are P1x is equal to, there are three. First one is what? 4x minus 1 in what interval? 1 less than or equal to x less than or equal to 2. Next, 7x minus 7 in what interval? 2 less than or equal to x less than or equal to 4. And the third interval, 13x minus 31 in what interval? This is 4 less than or equal to x less than or equal to 8. 4 less than or equal to x less than or equal to 8. And what is the next question? Hence evaluate f of 3. F of 3 means what? P1 of 3. 3 belongs to which interval? 3 belongs to which interval? This one. So this is 7 into 3 minus 7. See, observe, 3 belongs to the interval 2 to 4. Therefore use the polynomial 7x minus 7. In that one, 21 minus 7. Okay, 21 minus 7, 14. Now what is another one? F of 7. 7 belongs to which interval? P1 of 7. 7 belongs to which interval? This last interval. Therefore that is equal to 13 into 7 minus 31. So this value is 60. Okay, this is the piecewise linear interpolation. Now piecewise quadratic interpolation. Piecewise quadratic interpolation. Okay, here what is the thing? Let the number of distinct nodal points, nodal points means mesh points, nodal points be 2n plus 1. 2n plus 1. Why we are considering 2n plus 1? By this assumption, a equal to x0 less than x1 less than x2 less than and so on less than x2n will be the end point, which is equals to b. We are considering instead of xn, x2n as the end point. Okay, these are the nodal points, and we consider the groups of 3 consecutive nodal points. 3 consecutive nodal points. To get a quadratic polynomial, how many points required? 3 points. So we consider 3 consecutive nodal points as x0 to x2, x0, x1, x2. This is the first subinterval. Next subinterval is x2 to x4, x2, x3, x4, and so on. So obviously what is this? Xi minus 1 to xi plus 1. Okay, and last subinterval is what? x2n minus 2 to x2n. These are the subintervals having 3 nodes, 3 nodal points. On each subintervals, we write the quadratic interpolating polynomial. We write the quadratic interpolating polynomial using what? Again Lagrange's. One, not only Lagrange's, one can use Newton's divide difference also. Okay, for x belongs to, now let me write a general formula, quadratic interpolation. In the interval xi minus 1 to xi plus 1, we have what is a quadratic interpolating polynomial? Pi2. 2 stands for quadratic. Okay, pi stands for polynomial. How many data points here? Let me write here. Data points are what? Xi minus 1, xi plus 1. These are the x values, and the corresponding f values, fi minus 1, fi and fi plus 1. You know how to write Lagrange's polynomial for this data. What is that? Pi2 of x equal to, delete the difference x minus xi minus 1, write the remaining two differences, x minus xi by x minus xi plus 1 by, replace x by xi minus 1. So xi minus 1, xi plus 1, this is multiplied by function, this is f of xi minus 1, plus next one is what? Delete the difference x minus xi and write the remaining two differences, and in denominator replace x by xi minus xi plus 1 and multiplied by f of xi plus, and the last one, delete the difference x minus xi plus 1 and write the remaining two differences, and in denominator replace x by xi plus 1 minus xi into f of xi plus 1, xi plus 1. This is quadratic interpolating polynomial, is the quadratic interpolating polynomial. Okay, now let us consider one problem on quadratic interpolation piecewise. Obtain the piecewise quadratic interpolating polynomials, quadratic interpolating polynomials for the function f of x defined by the data what is the data is given as x versus f of x is given. This is minus 3, minus 2, minus 1, 1, 3, 6, 7, and the function values 369, 222, 171, 165, 207, 990, and 1779. Hence, find an approximate value of f of minus 2.5, f of 6.5. Solution. So to get quadratic polynomial we need how many points? 3 points. So we consider the group of nodal points. What is the first set? Minus 3, minus 2, minus 1. Next set is what? Minus up to minus 1 is over now. This is one set and this is another set, right? So minus 1, 1, 3, and another set is what? 3, 6, 7. On each of these subintervals we consider we consider quadratic interpolating polynomial. Okay, first one. What is the first one? On minus 3 comma minus 1. On minus 3 comma minus 1. What is the data here? Now on the interval minus 3 comma minus 1. What is the data? X versus y, minus 3, minus 2, minus 1, and the corresponding values 369, 222, 171, 171. You know what is the notations? This is xi minus 1, this is xi, this is xi plus 1, this is fi minus 1, this is fi, and this is fi plus 1. Okay, I will not write again the formula. Okay, now the quadratic interpolating polynomial is, what is the first one? P 1 2x equal to x minus xi, right? That means as per the formula x minus xi plus 1 by, replace x by this, so minus 3, replace x by xi minus 1, minus 3 plus 1, and the function value 369, plus next one is just substitute in the formula the values, x plus 1 by minus 2 plus 3 minus 2 plus 1 222, plus next one is x plus 3 into x plus 2 whole by, replaced by minus 1, x replaced by minus 1, and this is 171. Okay, after simplification, what I am getting, p1 of x equal to 48 x square plus 93 x, 48 x square plus 93x plus 216. This is the first polynomial. This is the first quadratic polynomial in over what interval? Minus 3 minus 1, minus 3 minus 1. Now next one on what interval now? Minus 1 comma 3, minus 1 comma 3. What is the data here? X versus f, minus 1 1 3, and corresponding f values 171, 165, next 207, and you know what are the values? This is xi minus 1, this is xi, and this is xi plus 1, this is fi minus 1, this is fi, and this is fi plus 1. Okay, therefore what is p22x in the second interval quadratic polynomial is x minus 1 into x minus 3. Just substitute in the formula the corresponding values. Okay, and this is minus 1 minus 1 minus 1 minus 3 into 171, plus next one x plus 1 x minus 3 whole by 1 plus 1 1 minus 3 165, plus last one x plus 1 x minus 1 whole by 3 plus 1 3 minus 1 207. Therefore what is p22x equal to? The result is 6x square minus 3x plus 162. This is the second quadratic polynomial over what interval? Over minus 1 comma 3, minus 1 comma 3. Now on the interval, last interval 3 comma 7, what is the data? X versus f, 3 6 7, and this is 207, function value 990, 1779. This is xi minus 1 xi plus 1, fi minus 1, fi plus 1. Therefore what is the next polynomial? Third polynomial. Third is quadratic. 2 stands for quadratic, 3 stands for third polynomial in the third interval. X minus 6 x minus 7 by 3 minus 6 3 minus 7 into 207, plus x minus 3 x minus 7 by 6 minus 3 6 minus 7 990, plus x minus 3 x minus 6 by 7 minus 3 7 minus 6 1779. This implies P32 of x is equals to 132x square minus 927x plus 1800. This is the third quadratic polynomial on what interval? 3 comma 7. Now what is the question? Since x equal to, what is the question? F of minus 2.5. Since x equal to minus 2.5 lies in what interval? Minus 3 comma minus 1. F of minus 2.5 is nothing, is equal to what? The first interval, that means p1 comma 1, p1 comma 2 quadratic, p1 comma 2 x, p1 comma 2 minus 2.5. The first polynomial, first subinterval polynomial, I have to substitute 48x square plus 93x plus 216. If I substitute, this is 48 minus 2.5 whole square plus 93 minus 2.5 plus 216. This is equal to 283.5. Next one, what is the next? Since another point is 6.5. Since x equal to 6.5 lies in what interval? Last interval, 3 comma 7. F of 6.5 is equal to p32 of 6.5, that is this interval. Okay, this polynomial is equal to 132 6.5 square minus 927 6.5 plus 1800 is equal to 1351.5. Okay, this is one example based on piecewise quadratic interpolation. Now let us see piecewise cubic interpolation. Piecewise cubic interpolation. Okay, here what is the change from quadratic to cubic? Let the number of distinct nodal points be 3n plus 1. In quadratic 2n plus 1, now here 3n plus 1 with a equal to x0 less than x1 less than x2 and so on. The last point is 3n, that is equal to b. And we consider, to get cubic polynomial, how many points required? 4 now. So we consider group of 4 nodal points, as what is the nodal points? x0, x1, x2, x3, 4 nodal points. Next one is what? Starting from x3, x4, x5, x6, right, and so on. And the last one is what? x3n minus 3, x3n minus 2, x3n minus 1 and x3n. And on each subinterval we write the cubic interpolating polynomial. Cubic interpolating polynomial using what? Again, Lagrange's interpolation. Okay, that is, for x belongs to xi comma xi plus 3, xi comma xi plus 3. Okay, we have the cubic polynomial. What is a cubic polynomial? How many points here? X versus f. Just for your idea, xi, I plus 1, I plus 2, I plus 3. One can consider from xi minus 3 to xi. You can consider like that also. Fi, I plus 1, I plus 2, I plus 3. Right? So what is the polynomial is pi3 of x 3 stands for cubic, equal to let me write directly. What is that? First one, delete x minus xi, write the remaining differences. Xi plus 1, I plus 2, I plus 3, and replace x by what? Xi, I plus 1, xi, I plus 2, xi, I plus 3, multiplied by what? Function at I. Next, second term is delete the difference x minus xi plus 1 and write the remaining differences. I plus 2, I plus 3 whole by replace x by what? Xi plus 1, xi plus 1, and what is the function value at that point? F of xi plus 1. And next one, third term is delete the difference x minus xi plus 2 and write the remaining differences. X minus xi plus 1, x minus xi plus 3 whole by replace x by xi plus 2. And the function value at I plus 2 point is f of I plus 2. And the last term is function value is xi plus 3. This is the Lagrange's cubic polynomial and piecewise over the interval xi to xi plus 3 only. Okay, now same problem, but do yourself. This is assignment. Obtain the piecewise cubic interpolating polynomials for the function f of x defined by same problem, x versus f of x, minus 3, minus 2, minus 1, 1, 3, 6, 7, and data points 369, 222, 171, 165, 207, 990, 1779. Hence find f of minus 2.5 and f of 6.5. Okay, solve this problem. The hint is here. The hint is first interval is what? On minus 3, 4 points, minus 3 to 1. So data is what? X versus f, minus 3, minus 2, minus 1, 1, 369, 222, 171, 165. So this is xi plus 1, xi plus 2, xi plus 3. Corresponding f value fi plus 1, I plus 2, and I plus 3. Similarly on what is the next interval? Only this one, 1 to 7. Okay, and what is the data? X versus f. Okay, here get what is the first polynomial? P1 3 of x. Okay, over this interval. Now here P2 3 of x over this interval. And what are the points? 1, 3, 6, 7, 165, 207, 990, 1779. Okay, get the polynomials and find the required values. This is piecewise cubic interpolation.